So welcome back, everyone. Next up, our workshop with NIKOLAI. And I think I'll just hand you over the reins and please start.
Okay. So I will start to introduce myself. My name is NIKOLAI SHTYKOV. I am Global Training and Education Specialist in coDiagnostiX. And today we will talk about the new feature as we have now in coDiagnostiX. It's called jaw filling functions. And before we start, I would like to say thank you for very interesting presentation, Nick and Brandon. There was very nice cases. I was like to see this and like to see how you're using the features as we have in coDiagnostiX. And what's actually new? I will start to share my screen. So I hope you can see my screen. And you can see the case here. This is a complex case, actually, case with the stackable guides. And the function, as called a jaw filling function, can be solved, can help us to achieve the good result with these kind of cases. Before I will show this function, I will also mention what we have in AI Assistant, because a jaw filling function, this is the one of the part of AI Assistant as we have. Normally, when we start our cases, we cannot see the 3D view like this. Usually, I will turn off everything, and usually we have 3D view like this. So this is just a default segmentation as we have in coDiagnostiX, as we received from the CBCT device, from the ConvinCT device. And if we export this in coDiagnostiX, we can manually make segmentation, of course, but what we can do with the coDiagnostiX, because when we export our ConvinCT, and when we exported our scan file, we can go to AI Assistant. We need to wait a little bit, so that's a live demo. Yes, and now you can see the perfect segmentation as we have in coDiagnostiX. If you need, you can, for example, if you don't need the maxilla jaw, you can switch it off. You can use it, you can leave it. You can change the tooth numbering if something wrong with the tooth numbering, but usually it's every time perfectly. And we can see the result here. Then, for example, let's switch off the maxilla. Then we can also see the patient coordinate system. I can edit it. Panoramic curve. Sometimes you can see that we need to make some editing. It's not a problem. And I really like the nerve detection, because the nerve detection, I every time check the nerve detection, how it's going. But in my practice, there is never case when I need to correct the nerve detection. But it's important to check it, because this is the patient and this is a nerve, and it is important part. This is important indication. So I go to the points. Next. If I need to make some editing here, I can do this here. And the left side. So it takes really less time than you can do this manually. And very nice feature that AI Assistant can make the alignment of our scans. And this is very important step when we do our alignment. How alignment has been done here, it will involve to the final result, because if the alignment will not be correct, your surgical guide also will not be correct. So, and this is very important step, and you still have option to do this manually, but I highly recommend you to do this with AI assistant, because actually you have the same functions, you save your time, you just put all of the data in AI assistant, and then you need to correct, you need to check. Actually, in this case, I don't need to make any adjustments. Yes, I can use the manual alignment, I can correct it. With the final alignment, I also can use the numbers here, arrows, to make this case better, or I can just click reset. So this is as we do with the AI system, and I import this data. I can turn off my segmentation here, and now we have this case with the perfect alignment data, or with the perfect alignment STL files. And if we go deep to this case, I already insert the implants. And this is our future position of the implants. You see that we plan to make a bone reduction here. We plan case the 4 implants, just for example, and I will turn on the bone reduction line profile, and you see that cut profile is on the way of the tooth number 7. And what we can create in this case, first of all, for this kind of case, we need to have the position of the pins, and then we need to create the bone reduction as well. Let's open in a full screen. And so if you have just a frame as a bone reduction, if you will create it, you see that this tooth is on the way of this frame. And actually the front teeth, there is enough to make the initial surgical guide. So we can do this in a different way. We can create this initial guide as a stackable with the frame. Yeah, maybe I can do this in the 2 steps. If you want to be more safe and have this guide solid, I can turn on the bone reduction, and you see that I have initial guide as a solid. Anyway, I need to extract this tooth. And how I can do this? I can do this in the old way in Mesh Editor, and I can also, because I did the alignment of the scanner with the AI system, with the right mouse button here, I can see the tooth extraction. And with the tooth extraction function, first of all, I can just extract. I have 3 different options: cut out with the and close, and cut out with the dental alveoles. For example, if I want to simulate the flap there, I can click cut out and close. If I want to place the guide on this place where will be like a virtual flap, it could be good to cut out and close. Or if this is another type of the case, for example, for immediacy surgery, there is better to cut out with the dental alveoles. And let's see how it looks. Also, you see that we have here the check mark that you can use this extraction tooth crown for the planing. It's no sense for this case, but if you do, for example, something aesthetic, it could be, this is really makes sense. And now we can make the tooth extraction. You see that it just takes a few seconds. This is not a recording, this is the real-time simulation, and you can see that when we will plan our implant, we can really understand where we will have extracted tooth and where we will have bone.
Yeah.
But for this case, let's maybe extract in a different way. I will show you firstly cut out. So cutout, this is really simple function, but what do we have here? We just have a hole, transparent hole. Actually, it is not helpful for us. Maybe this makes sense when you would like to make some bone support area and combine this STL file with the bone. You can do this.
Yeah.
If we want to simulate this here, so I can cut out and close. This is what I need for this case. I click apply, and now I can switch off this file. Also, I will switch off the bone reduction line. And here, because we can see the teeth as in segmentation here, so I need to switch off 37. And now, when I will plan my cut profile, let's find it here. So now I can place the bone reduction line and all of the steps here. So now it's more easy for me. But also you can virtually open the flap, etc. So for this case, I will place the bone reduction line on the bone, because how it will be. So we will place, for example, initial guide here. Then let me turn off this one. And let me turn off the simulation of gingiva. SHTYKOV and okay. So we open our flap, and then we need to place the bone reduction guide. We can do in coDiagnostiX simulation of the bone reduction to see when we extract all of the teeth, how will be the result, and also simulation of the bone reduction, or I can show you in live how it works. You have your mandible here. You can click on Edit Mesh. And here, for example, you have bone reduction simulation. You can click cut profile, sorry, and then you can see your profile of the bone reduction, and then you can click execute simulation. And in this way, system simulate the future bone reduction. But while the system is thinking, let's see on this case how it is. So here is actually a lot of holes. And why we need to close this? Why we have the jaw filling function? Let's click on Save as a copy, and now we will have this mandible copy. And let's create the bone reduction guide on this model with the holes, and you will see the result and the issues, what we could have and how we can solve it, and why we create the new function. So you select here mandible copy. Yes, that's correct. You choose with the cut profile. I have just one cut profile here. And then you need to select insertion view. I prefer to make it a little bit vestibular, because here will be the bone support case, and the bone reduction line will be close to the bone. It will not be, there will be less undercuts. You can also use the model before bone reduction, because the bone reduction line, the bone reduction simulation is not too necessary to create in the very first guide, because you will put this frame before you will provide the bone reduction, right? but the result will be the same. So here you can, usually I extend a little bit the height of the sleeve just to make it more solid, to make this guide, but it is not too necessary. And sometimes we have mixed support when there is a bone support and gum support, or some teeth support, very slow or low bone reduction, and you can choose some area or paint some area. But in this case, it's not necessary, so that's why I'm going next. And that's why, because I didn't put any support, any additional support. Offset is also in the previous one, in here is not necessary, because it will be affected only if you design something in the previous step, if you have the support there. So now I'm going next, and here actually offset is important. And here we have the minimum offset 0.3, and you have the bar width and the bar height. I use the 5 millimeter and 4.5 millimeter the bar height, and I use the same parameters for vestibular and oral side. Of course, I can, for example, for the maxilla cases, when I need to make this cut profile, I can switch off the oral side. I can include the palate, and it will be more stable. There will be fixation on the palate, and there will be frame on the oral, on the vestibular side. You can also use different parameters. For example, if you would like to have in the oral side this bar more thicker or thinner, you can make these parameters differently. But for the mandible cases, it's good to have similar parameters. Then we go in next. And now you can see these ones. And these islands, as we can see inside, this is not a big problem, but it takes time to remove it. There is few options how to remove it in the past, how we did it. So you can use, for example, inspection window and remove some of these parts with inspection window. You can save this surgical guide and open mesh editor and remove this in mesh editor. Or you can just print it and click to fix this STL file, and usually the software of the printer can remove this inside part from the surgical guide. But it was taking time, and that's why we created this function as called a jaw filling function, to improve this result, to don't have this result in the end of the in the end guide. Let's just finalize it. And now you can see this guide with these islands inside. And now let's see what is the jaw filling function and where we can find it. Here, where is the AI assistant, now you can see this small arrow, little arrow. If you click on it, this is a jaw filling function. And let's see what system show us. This is original. This is fillet jaw and fillet jaw with the sockets. What is the difference? If we click on it, this model could be very good for printing. For example, if you would like to print this model, system keeps all of the sockets, but close the holes in the jaw. And when you need to print this jaw, for example, for bone augmentation model, as previous speakers also used this bone segmentation for creating some bone augmentation, bone grafting. Yes, you can use it. You can easily print, and you don't need to spend a lot of time for preparing the model. You can separately export the tooth also, and you can print it, and you will have the better quality. Also, when you create the cases as a zygomatic case or sinus lifting guides, you can see the better bone quality in these parts. So all of the small holes in the jaw, they has been closed, and the jaw socket closed also. Here you see the simulation with also filled sockets. Why we, in which cases we need it? For example, in case where we're using right now, because I don't need to have the sockets, I need to have the bone shape here, but what happens inside, it doesn't matter for me, because there will be bone reduction, and actually I need to have the flat surface. That's why I will choose this one. I just click fillet socket jaw, and then I click import review data. And now we have improved jaw. So, and in the left side, you can see mandible here, maxilla here, and let's create the same surgical guide, but with a fillet sockets jaw. Let's create first maybe with mesh editor. We can use the bone reduction simulation, cut profile, and execute simulation. Also in mesh editor, you can see the point count numbers. Here, this is how heavy is our case, and it is a little bit lighter than we have it before. We have options here to reduce the triangles on this case, but you can see, so that's perfect. If you need to print this model, you can print it easily. You will not have these holes inside. You will have less issues. So let's click Save as a copy, because I wanted to save the original model as well. Or I can also show you, maybe we can cut this model a little bit. We have different functions here, for example, combine tool, cutting tool, smoothing tool, reduce tool. I will use deep eraser, and with the deep eraser, I will do this very roughly, like this. And when we cut this jaw, we need to close the holes here. It's not important, but I prefer to do this. And actually, it doesn't take a lot of time. And I go into repair mesh, and I can click, select, and close holes. So, and also you see that I cut this model, and now we have the same quality of the 3D mesh of this bone, but we have less count numbers of this. So this STL file is lighter. It's more easy to work with this for the computer, and for printing, and for all of the post-production process. I will save it as a copy. How we call it? Mandible fillet socket 1 copy. Okay. Then let's go to the guide design. Find the number when you work with such as a complex cases. When you upload a lot of STL files in coDiagnostiX, you can do this. You can upload a lot of files here, and this is very nice benefit as we have here in coDiagnostiX. But sometimes you have a mess when you have a lot of files there. So that's why sometimes you need to rename these cases. So I choose the model with the cut profile, And now we can see this. So I select again the insertion view. I'm going next. And let's do the same things. I like to do that. Maybe I will show you why I extending these sleeves, and it's actually doesn't matter even they go in inside of the guide. Actually, if they go in inside of the model, there will be also offset with the model. For example, this one in the middle I will not extend, and these ones I will extend. So offset, then I will not use the large connectors, the wall thickness, okay, we'll leave it unchanged. And here the settings is the same. And let's see on the result. So, and now was the result. And that was the reason why I extended these sleeves. You see that because this cylinder is just for a sleeve, and if we will not extend this, it will connect here. The pin will be inside, but because this is a pin, because this is a hole inside, I prefer to have a little bit more plastic here. That's why I'm doing this in this way. See? And now there is no problems with the islands inside of the surgical guide. So I can do next, I can apply, and next turn on this. And then I can use this guide and create actually osteotomy guide. And if I have prosthetics here, for example, I have prosthetics with holes. So this is my prosthetics design. And I can also use the prosthetic cage for transfer this one and to make the final adjustments. I think this is all of the news of the as we have now. Actually, this improvement of coDiagnostiX, this new feature, give us a lot of like improve our workflow and save our time a lot. Maybe it looks like not a big improvement, but really this is big improvement, and this improvement save a lot of time in the end of design, and we can finalize our difficult cases more easy and create these guides in more easy way. And let's see what we have. Do we have any questions? Stephanie, can you look? Do we have, can you see questions?
Hi, so far I don't see any questions yet. Some questions were already asked and have been answered. So yeah, anybody
So
have questions? Most time.
Yes, we're a little bit
faster.
Because I can show you a little bit more in this case, but as we announced for this lecture, there will be about the jaw filling function. And actually, I don't want to repeat, for example, the things as I showed in the previous user meetings. But yes, we can do this, of course. But what we are wanted to show. This is the new things. And the new things, this is a job filling function as perfectly.
So there's a question coming in.
Yes, can I please show the guide of the most other one? So which one you mean? The guide for transferring the key cage, or which one? I'm sorry, I'm not get the question fully.
Yeah, I think he wrote yes, so that was the one.
Okay. If this is about cage, I will show you. This is kind of tricky way, but interesting. So this is coDiagnostiX. We every time have a lot of different instruments to achieve our goals. And
So
yes,
somebody
can I-
else would like to know how to do this.
Of course, sure. I will show you both things.
So,
Okay, let's share the screen. That's really good that we finalize it a little bit faster. Okay, let's start with the pins, and then we will go into the prosthetics. For the pins, it's actually no any complicity because you can see the pins here, and when you need to put any pin in your case, you just go into step number 5, where is the implant. If you change your positions of the steps, it could be another step, but you will go. You need to go to the guide to the implant design, and for example, implant selection. Where is my favorite implants? So here we have the favorite implants on the top. I choose Straumann. And we have different pins here. We have pins for iGuide, but it's not for all of the countries. This is a new guide systems, but not every countries have it right now. And we have conventional pins here. For example, you need to choose the pin, you select the area where you would like to place it, you click on OK, and the pin is here. So, and then you go in, don't forget to centralize the view on the pin, because if you will not do this, it's difficult to find your pin. That's why center the view on this and going to insert the pin. When you place the pin, be careful about this small green line. This small green line, this is the crystal level of the pin. So this is the limitation of the sleeve as we have. So when you place these pins, if you plan to place the pin before you open the flap, you need to have this green line not in the gingiva side, so it should not touch the gum. If you will open the flap, for example, in this case, it's possible to open the flap before, then place the positioner guide, the initial guide, and then drill for the pins. But in some cases where you start with anesthesia before you open the flap, so you need to place it to don't touch the flap, and then you need to select the sleeve for this pin. You can do this in step 6 in my sequence, or here, for example, sleeve. You select it, and here everything is intuitive. It's here, so. And you don't need to make any other selection. Just click on close, and that's it. And right now, you can see that the pin is in the place. I will remove this one last because we don't need it here. And now we're going to import our design. To import our design, so I have here the wax up. For example, I have wax up without holes, and what I can do, I can create the holes in this initial wax up as I transfer it from the CAD software. I can transfer it from any software, for example, from SmileCloud. If I plan the smile of the patient, actually today with a SmileCloud team, they announced the new function as the 3DNA, and now you can export the prosthetic design in the same coordinate system and use it for the planning for coDiagnostiX. Or if you're using another software for planning, you can use CareVisual, Lexicad, 3Shape, whatever you want. And you can make your first row planning, even you can use the wax and the plastic teeth for this and then scan them. So everything is work. And then you have this scan, you use it for your planning. And how you can, for example, make holes in this. You can use, you see the wax up with no holes. I can click Convert to Model. And if I click Convert to Model, I have this wax up here. And if I look on the implant selection, my implants there with the different angles installed there. But I have screw retainer abutments here in this case. That's why I will select abutment level here. And you see that I have some presets. I designed some presets for SRA abutments to have the small hole, or I can create the new preset. And with this new preset, with the new analog, I make it very long. And you see that in this designer, you can add some segments, you can change the diameter, and there will be like a future hole. If you would like to have the hole bigger for temporary copying, you can make it bigger, or you can leave it for the small hole, like this, for example. Or I can change it for my preset for SRA hole. You see that I create this like this. So I just measure to have some space with the for the temporary copying, but you need to be precise because you need to glue this temporary copying one by one, because you will not have space to place it like just from the top. And then I click OK. And then okay, let's this one, and this one. So now I have all of the copying inside here. And there is the option subtract implant analog on the model. So you click on next, next again. And you see these cylinders. I'm going next again. And there is the model with the holes. Now you can use it, you can send it back to the CAD software, or it doesn't matter, you can just print it, and that's it. You can edit in your planning. So now we have it here, wax up, no holes with analogs. You see it here. For the cage, we need one more model. It will design in the same way, in totally the same. So I need to have the same model with no holes, or the model as I just created. Let's make new one where it is convert to model. And I also using, because I need to have in the future guide the big hole to understand where will be cage, and to understand to have access to the screw channel. And for this, I created a really big hole, 8 millimeters. So this is just diameter, 8 millimeters. If you don't like, you can create another one, maybe 10 millimeters, or maybe 5. And the difference is, so I don't need to subtract now them from the model. I need to merge them with the model. I just click, 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 and I have the model with these cylinders. And now if you go next, and next again, and then you can add this model. So let's see the name, works up, no hold with analog. Let's rename it full cage. I created this model, and now what I need to create the surgical guide, like the cage, which will be maybe with the pinholes, or as a stackable. I can also save the frame here in the position, and to correct the position to make this cage stackable. Maybe let's make it more interesting with a stackable cage, because we are trying to see that what more we can do in coDiagnostiX, right? So for this, what I need to have the frame, this frame, the bone reduction guide. What I designed here, let's find surgical guide 4, right? Okay, let's convert it into 3D model. I have surgical guide 4. Okay, and I open it in mesh editor. So now I see it here, and I also opened here, I combine the model, and there is the thing that I combine it not with the model, with the cylinders. I will use it later. I combine it with the just a normal wax up as I have. Wax up no holes, or wax up with holes. This is with holes. Doesn't matter. We can see with the holes. So then I merged it. This, click and apply. And yeah, apply. Let's apply and rename 1, 2, 3, 4. And now let's go to design. So we prepared all of our files, and I choose the model 1, 2, 3, 4 as I just designed it here. So I don't use cut profile. Just go next. Select insertion view. That's important step, because the insertion, as you will select here, there will be like how your prosthetics inside will fit perfectly inside of this cage. And you need to see as much quarters in the model as you can. I think this could work. Yes, then we go next. And for now, I turn off this. I turn off all of the implants as I have. But I have also pins. And what I prefer to do, to extend the wideness of the pins, to make it maybe 12 will be okay. And then I need to design something here. It's better, I recommend you to start from the middle. So start here and make this area really big. and one more. So I think we have one more tooth here. You can make a mixed support on the frame also with the buccal sides here. You could think that it could be a problem that the plastic will be inside of the holes, but no, it won't be. I will show you later why. And here as well, you can use, for example, the draw tool to fix some areas. Okay, let's go next. So for this, offset is important because you will print on your prosthetics and you need to put it inside. But I cannot say which offset you need to use because it depends on the 3D printing of all of the process of the cleaning, of the curing, of the resin, of the calibration. And mostly when I working with a calibrated good printer with the 3D with the 3D objects as I designed, and I don't have scan of the object, I have 3D model of the object, and I put it virtually before. So in these cases, I using the small offset. Maybe it could be 0.1, but in some cases, if you have some problems, it could be too tight. Maybe you can use the offset bigger. So you need to try different offsets and try with this. Maybe let's try with the latch connectors, or maybe it's not important. No, let's try without. Then go next. Anyway, if you don't like design without latch connectors, you can go back and create them. Yeah, that's not bad without them. So this is our first design. Here is a problem inside, right? There is a hole, and actually we need to open these parts. I used to open this with inspection windows. I just put it in the H and make this H really big. Make this inspection window really big. You can also ignore this function and just print guide without cutting this area, and then when you print this guide, just drill one time with the bar and the bore, and that's it. But I prefer to do this everything in advance. I like to have the good STL file and doesn't take too much time. So I think it's okay. And then we need to open the area here. I also use inspection windows. And maybe, yes, this position is not bad. And now we need to have really a big inspection window. Maybe like this, not bad. One more. So I don't need too much support. I just need to have a frame, and I need to have this guide, just a little bit support of it, and I can just use the teeth here. So I think, yeah, that's okay. Maybe I can also do this in the middle. Oh, maybe that's enough. Let's see. No, maybe too thin. Okay, let's do it like this. And what's more, because there is some holes, and these holes, on this one, the last one I will delete. These holes, they are not following, so we need to open just one hole maybe for the screw is okay. But we created here, we have the add object function, and why we created the one more guide design here. I think this one, yes. So now we have this model with the cylinders. And what I need to do, I need to subtract this model from the cylinder because this is exactly the same prosthetics. This is just the holes which follow in the direction of the abutments. And important thing here, so first of all, you click here, not integrate, subtract, offset. You don't need to use any offset. It's also important because you put the offset before, and now you have to use the same STL file. And if you will put some offset here, you will increase it, and your prosthetic inside will not fit really well. That's why you don't need to use any offset. And because this object is going like out of the model, and I don't need to remove any overhang here because we have different options to the insertion direction, opposite insertion direction. But in this case, I don't need, I just need to subtract it. So I click on OK, then I go next. And that's it. And this is the cage. And of course, if you're not happy with this design, for example, I think it's not bad, it's workable, but you can improve it. You can maybe make inspection window here. Actually, in this kind of design, yeah, we could have some place to hold the prosthetics, and we still have the holes for where to put the screw and to put the glue when you will connect your copings with it. So for right now, we don't need this model as well. Let's turn off everything. And this is the way how to create this cage. Where is the with holes? Yes, this one's. Awesome. And actually, with this explanation, we are exactly in time. And I'm ready to respond for more questions.
Yes, so there have been a few more questions. Look at the question box.
Okay.
We wanted to see what a draw hole filling is, the feature. We just need to mention that not all regions have this update yet. That will come in the next few weeks.
Yes, it will come in. Yeah, thank you, Stephanie. Yeah, not all of us have it.
If you can show again where to find it when everyone has the update, then.
Yes. If we have angled implants, how you make the holes? This is the same. I have angle implants because in this case, as I showing you, there is two implants. They are straight in the middle. They have the straight abutments, and the buccal implants, they have angulated 70 or 30 degrees. I can check. You see that abutments, they are angulated here. I hide it. My mouse doesn't work well. You see that abutments implant is angulated. Let's find it here. It is 17 degrees. And because I can choose the position of the screw of this cylinder as I subtract the following direction, not from the implant. I subtract it from abutment direction. So I put the abutments in advance, and that's why it's important to have it in coDiagnostiX to put abutments in advance, because you also have options to rotate it. You can see the screw channel, you can rotate and understand where will be the angle of it. And what I also like to use when I rotate them, I use the option angle between abutments, and I see that system gives me acceptable deviation, and the deviation is I have right now. For example, this is the deviation as right now is 8.1 is the maximum. So right now it's 15, 24. So I can do this better. I don't need to have 0 degrees. Of course, it's good when you have 0 degrees, but you don't have possibility in all of the cases have a 0 degrees, because sometimes there is no bone, there is the teeth as you need maybe to use before, or so something could be there, the nerve canal, and that's why it's not possible every time to place the implants parallel. Sometimes we need to make it with angulation. And it's not a problem if we have some deviation, because screw retaining abutments, they allow us to do this, and you see this deviation. Just the one thing, as much deviation you have, as more difficult to put the prosthetics just from the top, just like drop it on the temporary abutments. You cannot do this because you have deviation. That's why I told you that if you have deviation, and if you don't want to have the really big holes inside of the prosthetics, you need to glue them, glue one by one. So you put one coping inside, then you put the prosthetics with the cage, then you just fix it gently, then you unscrew, remove the prosthetics, put another one in the prosthetics, screw again, and when you do this one by one, it takes more time, but the benefits that you will have small holes. So that's just because of this. If you don't want, yeah, you can do this more easily, just with the big holes and drop it. Okay. I will read more questions. To put the titanium cylinders over the SRA. Yes, that's what I'm talking about. Or you mean that which titanium cylinders? So because I created this cylinder, this is like a continue of the SRA. There will be our coping, and you have space there. So you know the diameter of the future coping. So when you buy the coping, there is diameter there. In the system, you can also see the article numbers with all of diameters. And it's not a problem. You see that diameters is every time follow the SRA button. So if it's 5 millimeter, it will be fully enough. I just did it. I did some measurements and did it more gently. If we use angled abutments, how to make holes? Could you show one more? So let's say showed. Can you show us how to put the pins? I did it. I think I respond on all of the questions. So could you show more? There I see also the Benjamin. Thank you for responding. Yes, and do you have more questions? Stephanie, you muted. You muted.
Yeah, I think that's it. You've answered all the questions. So yeah. All right.
Thank you. That was pleasure to read your questions and respond on it, and to be helpful for you and enjoy the new features of coDiagnostiX. And because this is our tool, has given us to create really challenging cases, easy cases, and of course challenging cases. And no one's in the market can do this this challenging things as we have. So that's happy to share this experience with you.
Okay, thank you so much, NIKOLAI.